Okay, so for number 3, the rule of 70 says that the doubling time is 70 over the interest rate. So in this case, 70 divided by 4.5, and that gives us 15.6 years. So to find the exact doubling time, I'm going to change my percent to a decimal. But to double p, my balance will be 2p. Now when I divide both sides by p, we get 2 equals 1.045 to the t. I'm going to natural log both sides so my exponent can become a coefficient. And to solve, I'm going to divide both sides by the ln of 1.045. We get 15.7 years. So when we start off with x squared, our new functions, 3 units up is add 3 at the end, and 2 units to the right is you subtract 2 from your x. Reflected over the x-axis is a negative in the front, and down 4. Stretched vertically by 2 is a coefficient in the front of 2. But vertically shrunk by 2 is a coefficient of 1/2. And then lastly, 4 units left is plus 4, stretched by 3, reflected over the x-axis. So the first thing I need to find here is g of 2. So when I plug 2 in for x, I get 1. So now this is f of 1, which is 1 squared, and that equals 1. For b, I first need to find f of negative 1, which is positive 1. So now g of 1 is 1 minus 1, and that equals 0. G of 3, that's 2. So now h of 2 is 4 times 2, which is 8. H of negative 2 is negative 8. Plug it in here. So f of negative 8 squared equals 64. Now with all variables, f of g of x. So I replace the x with my new function. So for f, we're going to take the h function and plug it into g. So that instead of the x here, I'm going to replace it with 4x, and then I bring down that negative 1. So f, I take the 4x and I plug it into that x there. I could simplify this, and this is 16x squared. And then lastly, The x in the g function gets replaced with x squared, and that's all I can do. Now, for number 6, there's multiple options for answers. I need the inside and the outside function. Well, if I make the inside function x squared, so I'm going to say g of x is x squared, that means f of x is x plus 1. So here's my answer for A. For B, the inside function is x minus 1, and the outside is x to the third. And for H, this last one, my inside function is x minus 3, so what we would substitute that into would be the ln squared of x. Okay, even is y-axis symmetry, odd is origin. The way we can figure that out is if we plug in negative x, do we get the original or the opposite of our original? Negative x to the third is negative, times this negative, so we get 3x to the third here, minus 2x. That is exactly the opposite, so A is odd. Now for B, should be f of negative x. We get negative 4x. That again is the opposite, so B is odd. Now for C, a negative to an even power is positive, so we get the same function again, which makes C even. For D, the first x is negative and the second does not change, so this is a mixture, so D is neither. Now the cube root of negative x is the same thing as negative the cube root of x. So that's the opposite, which makes E odd. And now for F, I'm just going to sketch a graph. Y equals 0 is a horizontal line here at 0. So that's actually both even and odd. Has origin symmetry and y-axis symmetry. Before I do anything else by filling in the chart, I want to make sure all of these are written in a way that will make the chart easier. So for example, B, this 2 needs to be factored out so I can get my period change. So pi over 4 divided by 2 is pi over 8. So that'll change your phase shift. And then C, I have to do the same thing. And I'm also going to move this 3 to the other side. Okay, so now I can fill in my values. Amplitude is 1. The period is 2 pi over b. So in this case, that's pi over 2. My phase shift is to the right, pi over 2, and there is no vertical shift. For B, I'm going to look down here at my red equation. Amplitude is always positive, so it's just the number, not the negative. My period again is 2 pi over B, the number in the equation, which is pi. This is left pi over 8 and down negative 3, or down 3. Lastly, for C, amplitude is 2, period is 2 pi divided by 3, to the right pi over 3 and down 3 again. Okay, for graphing, my amplitude is 1, so I'm going to go up 1 and down 1. And I'm going to start at negative, to the right, pi over 2. My period is 2 pi, so the value out here I need to find by adding 2 pi to pi over 2. I need a common denominator, so that's 5 pi over 2. Then I need the midpoint. The midpoint is if you add these and divide by 2, so that would be 6 pi over 2 times a half, so 6 pi over 4, which is 3 pi over 2. And I need the halfway marks again. When I add these, that's 4 pi over 2 times a half. It's too much to do in my head. So that's 4 pi over 4, which is pi. And then one last time, that's going to be 8 pi over 2 times a half, which is 8 pi over 4, so that's 2 pi. To sketch my graph, sine starts in the middle, goes to the max, back to the middle. Oops, I didn't start in the right spot. This is my new starting point. Minimum, and back to the middle. Okay, so for B, I actually have to rewrite this before I can start. Pi over 4 divided by 2, that's pi over 8. So I'm going to start to the right pi over 8, and this time my period is 2 pi over 2, so it's just pi. So pi over 8 plus pi is 9 pi over 8. So then to find the middle, so I need 3 more points. The middle here, that's going to, when I add them, it's 10 pi over 8 divided by 2, so that's 10 pi over 16. And that can be reduced by 2, so 5 pi over 8. Then here, when I add these, that's 6 pi over 8. Then I need in the middle, so that's 6 pi over 16, which is 3 pi over 8. Then I notice a pattern, 1, 3, 5, so this one here is going to be 7 pi over 8. And now I see 1, 3, 5, 7, 9. Cosine, oh, I didn't do my amplitude. It goes from 1 to negative 1. There's no amplitude change. Starts at a maximum, goes to the middle, minimum, middle, max. And I have my graph. And last but not least, C. I have to reorganize some of this as well. So when I make my graph, I'm going to start down at -3. I like to put a dotted line to help me remember that's my middle. Then I'm going to go up 2 from there, and then down 2. I start at the right pi/3, and my period is going to be 2 pi/3. Well, I need to go that many units away, so 2 pi/3 plus pi/3 gets me to pi. And I need the halfway mark. So to find halfway, pi/3 plus pi times 1/2 is 4 pi/6, which reduces to 2 pi/3. And I need the halfway again for each one. So 2 pi/3 plus pi/3 gives me pi, but I need half of that, so this right here is pi/2. And then lastly, 2 pi/3 plus pi is 5 pi/3, but times 1/2, so that's 5 pi/6. And when I go to graph, it's sine, so we start in the middle, maximum, middle, minimum, maximum. Okay, so to sketch this quadratic graph, I first want to know where the vertex is. So I can find that by doing -b/2a. It's -130 divided by -2. And that gets us 65. But then I need to know how high, so if I plug that value back in, we would get 4,000. So right here, 65, a max of 4,000. Is where my vertex is. So what price should be charged for a maximum profit? Well, that's the maximum right here, so $65. What is that profit? That's our y value, it's 4,000. And for what values is the profit function positive? So I need to know the two x-intercepts. Oh, my units are off here. It's not actually $65. If the profit function's in dollars, but P is in cents, this is not $65, that's actually 65 cents. So a decimal point there will make a difference. But profits in dollars, so $4,000 is still correct. So these, I need to find these cents versus dollars here. So for D, I'm going to take my quadratic and set it equal to 0. you can either use quadratic formula or factoring. I'm going to stick with quadratic formula. So using my calculator, I get negative 130 plus or minus the square root of 16,000, all divided by negative 2. And when you do negative 130 plus the square root divided by negative 2, then you have to do negative 130 minus the square root divided by negative 2. My answers are 2 cents and $1.28. Okay, so for number 11, for A, it's a polynomial, and I see my zeros are at negative 3, so I do plus 3 here. And then this one's a repeated because it touches and skims, so when I write that one, I need that squared. But now I have to find out A. This point right here is at the coordinate 0, 3. So if I plug that in, I will be able to solve for A. So I get 1/9 is A. So my final answer is I have to replace that A with 1/9. Now B is sinusoidal. It is not just any polynomial. It is a repeated pattern. So I know it's going to be a sine or cosine graph. Because it goes through the origin, I'm going to pick sine. And that means it's not going to have any phase shift. My amplitude, let's see, it goes from 3 to negative 3, so it has no horizontal shift, and I know my amplitude is 3. The period starts here, and the pattern repeats at 18. So B is 2 pi over the period, which is pi over 9. And for 12, so if high tide is at 4:15, I'm going to write that as a decimal. It's 4 1/4 because 15 minutes is a quarter of an hour. And it's 5.2 meters. 1027, well, let's see, 27 divided by 60 is a decimal of 0.45. So 10.45 hours past midnight is a depth of 2 meters. So there, I changed my decimals. I'm going to make a quick sketch, just helps me. So at 4 1/4, we're at 5.2, and then at 10.45, we're at the low tide. So if I find the hours in between here, that will be half my period. So 10.45 minus 4.25. This is a length of 6.2. So if I go 6.2 out to the right, I get to 16.65, and that's when I'll be back at high tide. So a quick sketch of my graph. So I know my period is twice of 6.2, which is 12.4. My amplitude is my maximum minus my minimum divided by 2. That's 1.6. My vertical shift is my maximum plus my minimum divided by 2. And am I forgetting anything else? Oh, my phase shift. I'm going to choose cosine because that's the max is over here at 4.25. And I get my equation. So find the depth of the water at noon. I will use my calculator for this. Noon is 12 hours, and I'm going to plug that in for x. So instead of x here, I'd plug in 12. And using my calculator, I get 2.5 meters. And lastly, for C, if it's afternoon and it has to be 3 meters, I'm going to plug y1 is my equation, y2 is going to be 3. So here's that line at 3, let's say. Not very straight, sorry. So let's say 3 is about here. This line, if I find where my graph intersects here and intersects over here, I'll know that that's when the water is above 3 meters. So using the calculator, this point is going to be around 12 point, almost 13. Okay, I thought because some of the buttons can get tricky, I would load my computer to show you how I'll actually use my calculator. When you type this in, make sure you have parentheses around your fraction. And then in y2, I put the 3. And now for my window, I'm going to stop and think about the situation to put in the actual numbers. Don't use any of the zoom settings. So my 0 time is, my x minimum is midnight at 0. My x max is, I'm going to say midnight the next day at 24 hours. My y minimum is 0, and my y max, I'm going to make 6 since 5.2 is how high the water goes. I'm going to make sure I'm in radian mode, and I'm going to press graph. Okay, so afternoon is from this point all the way over to this point, and that's what I was trying to draw here. So I'm going to do second trace, intersect. I'm going to arrow over to that point and hit enter 3 times. And we get 12.79. Then when I get the other point, so again I'm going to do second trace, intersect. And I don't want to trace all the way around. I'm going to hit the down arrow, and that puts me on y2. So now I can go straight across. And then hit enter 3 times. And that gets me 20.5. Now I need to change these back to minutes. So we need to know what over 60 equals 0.79. So if I do 0.79 times the 60 minutes, that is about 48 minutes. So at 12:48 p.m. and then 20.5, well 0.5 is 30 minutes, and now 20 is how many hours past noon. so this is 8:30 p.m.